Friends, from time to time I go back to review some of my work and remember them in my groups. Forgive me for being a bit heavy. In this case I would like to talk a little about my ideas about the number pi, and expose mine. A subject to review is my vision of the total logical structuring of mathematics and its geometric concepts. For me, mathematics is a pure and strict logical norm, and therefore these requirements are always and everywhere met. And with regard to the circumference and its magic and elusive number pi, it must also keep these principles of accuracy, mathematical logic, geometric logic, etc. And based on these premises, I would like to distinguish my pi number, the squaring pi, which I understand meets these requirements, from the current or algorithmic pi number, which I understand does not meet the most important ones. Let's see. 1. The circumference is perhaps the simplest and most regular geometric figure, and therefore it should comply with the standard and logical mathematical principle that all formulas for measuring and adjusting geometric figures are based on their structural parameters such as radii, diameters, sides, angles, perimeters, hypotenuses, legs, apothems, etc. It is not expected that parameters or numerical values that are not in these parameters will be used to construct or measure the geometric figure. That is, both mathematically and geometrically, the figures are composed, structured and measured by means of their parameters. However, the current algorithmic pi does not do it, but uses a series of values not connected to the parameters of the circumference, due to the fact that it seems that its results are getting closer to it. Logically, and if the geometry and its numerical values are serious and demanding, they should not give us the true final value. However, my pi number is based on a direct formula of these circumference construction parameters, mainly its diameter. For this reason, I believe that my pi number meets the first and obligatory condition, which is to be measured and adjusted with the values of its parameters, diameter. 2. Another interesting and simple way to adjust the squaring pi number is to use the phi number for it, as shown in the drawing. Asterisk. Of course, the squaring pi website details multiple properties and ways to see, measure and adjust this number. 3. Another property that I have observed in the circumference is that it can be perfectly inscribed within a square, which is also defined and built, its side, by the same diameter as the circumference. But it is also that, and from any circumference, we can go on inscribing and circumscribing other squares and circumferences to infinity, all of them being built and supported by the previous ones, that is, with the elements of some we build the structure of the others. Well then, all these squares and circles circumscribed between them to infinity should have the property, circumscription theorem, that any basic element of this structure, and in the form of an exponential formula, has a formula that is capable of measuring and adjusting all and each of the elements of all these circumscribed figures, one above the others. And yes, exponential formulas of my number pi, they can give us all the measures of the elements and circumscribed figures. Squaring pi website. But no, the current algorithmic pi does not comply with this property, and if it is applied, it moves further and further away from the correct measurement. 4. And finally, an observation or conclusion that I have obtained. Sometimes, many times, when I get a little bored I dedicate myself to squaring circles, and I have observed that many of the possible segments and arcs inside the circumference point to the place where we have to place the segment pi divided by 2, but they do not finish achieving their total accuracy, for which I understand that it is due to the fact that to find pi, the basic parameters, radius, diameter, etc., must be subjected to many roots and powers. For me the minimum root and key is 17,